So this is the high current circuit I've been looking at. So we've basically got here is a number of transistors to raise the voltage of the PWM up to 12 volts so that this MOSFET can then drive this collection of fans. It's about an ampere or so. It's not massively heavy. I can't get much more than that because I don't have enough connectors, and but at this kind of current the transistor does get a little bit warm, so it will need heat sinking obviously. And ultimately I won't be using this particular transistor, it'll be a different one which may be cooler anyway. So just to show, I've got the PWM box here. I'm just going to increase the size and duty cycle to the fans, and they go right up to 100% at 1 amp, and they go down to about 0.2 amps at the slower speed. They're still kicking over at the slower speed, most of them. Some of them will pause. Yeah, okay, they do kick out. I would say about 10-15% they'll all start kicking on. There we go, so that one's just started going up there now. On the scope, you can see there's my lower part of the duty cycle, and that's the on bit of the duty cycle. There's a little bit of curvature there. That's because of the inductive load, and fans aren't an ideal load. So you get a situation like that when you've got so many of them. Got some transients here. I've got a diode here. This is a Schottky diode, which should help suppress a lot of that, but I think the fans themselves have that inbuilt anyway, so it shouldn't be a problem. And it's probably the fact that it got so many of them in parallel with each other that's given these transients here. So as I increase the duty cycle, you can hear the fans getting louder. There's a problem with trigger in there, it's sort of going between two triggers, but you can see that the duty cycle just goes up to a max. Get no transients, tiny little transient there. I'll zoom in on that. There it is, there's the little transient, which, I mean, you're looking at 2 volts per division here. It's just nothing to be concerned about. The concern there would be if it was a massive transient, maybe sort of 30-40 volts, which you can get sometimes. So back here, we can go back down again. So it just goes to show that the this can work. I'll probably use a logic level MOSFET with a lower on resistance, and I'll have a look at that next time. But so far so good. I can, if I get hold of a motor of some kind that drives about 2 amps, then I could prove this.